whether you are just planning your data collection or whether you've started or whether your data collection is finished and you've just got analysis to do. All right, let me see if I can make my slide share again. See if I can see the chat at the same time. All right, cool. Can I get a thumbs up that you can see my slides? Yes, thanks, Tiana. All right, let's kick off. So, welcome everybody. Thanks for coming. Um, Today's workshop is going to cover a portion of the hidden curriculum, as I call it, that is so deep that I think you'll come away with some ideas that you've never really heard of before. But those ideas will save you many, many hours of pain and suffering down the line. So you can follow along with these slides using this URL. These slides live online and will continue to live at this URL. So if you want to use it now to open them and follow along, or just bookmark it so that you can come back to them later, yeah, you're most welcome. All right. For those of you, there's some new names on the chat, which is great. Welcome. For those of you who don't know me, my name is Jenny Richmond. I'm a developmental psychologist by training. And for about 17 years, until last year, I was on faculty at the University of New South Wales in Sydney in psychology. And in my time there, I supervised maybe 35 honours students and PhD students. At the end of my time there, I was the director of academic program, which meant I was kind of the educational leader, governance person on that looked after all kinds of things like accreditation and faculty review and new programs. And through my time doing that over COVID, I got a little bit burnt out. So last year, I resigned from my position at UNSW. And since then, I've been working out what I want to do with my life. It's kind of funny to be in your mid-40s and it's like, all right, what do I want to do when I grow up? And working with students and uncovering this kind of hidden curriculum in research training is the one part of my old job that I really miss. So what I have done in the last couple of months is set up a research consulting firm called Reveal Research. And what my goal is to make research training less painful, particularly for students who are not doing it in traditional labs where there are lots of other people to learn from, right? So there are lots of things about research training that I call the hidden curriculum, things that you're just supposed to know, but no one has really explicitly taught you in a research course. And when you are doing a research project in a lab where there are PhD students and postdocs and other people to learn from, these kinds of things, you kind of learn them socially in the lab. But if you're doing your honors project in one of these rapidly multiplying online programs, you're kind of all by yourself trying to learn these things that are a bit painful to learn by trial and error. So what I am doing is helping students, particularly those who don't have a research community to learn from, navigate research training via one-on-one and group coaching, via writing review. So if you have a piece of writing, whether that's an assessment, a thesis chapter, or a whole research thesis that you would like some really detailed personalized feedback on, I do writing review where I give you audio feedback and can talk you through what's working in your writing, what's not working in your writing, why I think it's not working, and what you might be able to do about it. And then workshops like this, which are live on Zoom, covering the bits of the hidden curriculum that I think are most underappreciated by students. So if you're interested in maybe working together, this pink link at the bottom, you can book a discovery call and we can chat about how I might be able to support you in doing your research. Okay, so what is research data management? Now, I have had a number of conversations with students over the last few weeks, and whenever I say, "Oh yeah, the next workshop is about data management," they kind of look at me with this like really puzzled look on their face, like, "What is that?" And I think that's because it's this missing step between your data collection and your analysis, that's actually supposed to happen before your data collection. That makes the whole process easier, but you don't really know about it until you experience the pain of not doing it. So when we're talking about a broad range of activities, we're talking about everything from thinking about how you structure your project, thinking about how you name your files and how you name your variables within your files, thinking about how you back up your data and keep it safe, thinking about how you keep track of all the versions of all the files that you've got, right? Things like that. And one of the things that I think it's hard to convince students, particularly when you're only planning you've got a 12-month project, it's hard to convince you that you should care, mostly because when I read about, okay, why is data management important? The first half a dozen things are why it's important for science in general. So open science, the open science movement would argue that data management is a key issue in the replicability crisis and the reproducibility crisis. A big part of the reason why science tends not to replicate is that the scientists doing it are not documenting the process of collecting their data in sufficient detail. And if we all did that better, then it's much more likely that you'd be able to replicate the effect, right? But for those of you who are just doing a 12-month project, the idea of solving the open science problem seems too big, right? The other reason that is often cited of why we should care about data management is that granting agencies require it. So if you get a grant from the Australian Research Council or the NHMRC, they will require that you submit a data management plan before they will release the funds to you, right? But for those of you who are just running a 12-month honours project, that's not a reason to care either, really. Your project isn't funded, so why should you care? I argue that you should care because not thinking about data management can result in suffering, right? So this is Crystal Lewis. She's a friend of mine. She's one of the co-founders of Our Lady St. Louis in the US. And she is an independent, she used to be an education researcher, and now she's an independent data management consultant. And she posted this on Blue Sky a few weeks ago, saying that she went to speak to a graduate class, like a PhD student class, about research data management. And they asked her, how do people become convinced that doing something about data management early in a project is worth it? And she said that suffering, they usually have to suffer first. And this is the problem with data management, is that you don't know how you could have prevented the suffering unless someone tells you in advance of the things that you should do, right? Sarah has done research before. This is not her first research train, and she's commenting in the chat. LOL, this is so true, right? So my job today, I hope, is I just want to prevent you a little suffering, okay? So in order to convince you that some of these things are worth doing, we're going to start today by engaging in a little vicarious suffering, right? So I asked Claude, who is my favorite AI, to generate me some examples of data management problems that resulted in small amounts of suffering. That was either you had to redo something, or something took a long time, or you did something and ended up being embarrassed. So we're not talking about catastrophic examples, but I asked Claude to generate me some examples so that you can get an idea of the kinds of suffering that you might be able to prevent yourself having to engage with by doing some of the things we're going to talk about today. Okay, let's start with some vicarious suffering. First scenario. So Lena has just finished testing 100 kids for her honours thesis, and she collected her survey data from their parents on hard copy forms. She had them writing on these forms with a pen. She entered the data into Excel and stored the data in a data folder on her laptop desktop. Then she spilled a glass of wine into her laptop, and it refused to turn on. She had no backup, and so had to spend another 4 hours entering the data again, right? So that's not, I mean, it's pretty disappointing. It's not terrible. You just have to redo really tedious work, right? But part of data management is asking yourself, how will you keep your data safe? So ideally, you don't want to store it only on the desktop of your laptop. I would avoid storing it on any kind of external device, a USB stick, a hard drive. Those things are like, I feel like they are just recipes for corruption. Those drives will corrupt and then you will have no data, right? Ideally, you want to store your data in more than one place, but you want to store it in a place that is backed up automatically to the cloud, right? So often the lab you're associated with will have a shared server. That's a great place to store your data because it's backed up to the cloud and it's backed up off-site. So even if your lab building burned down, your data would be okay. Cloud services like OneDrive or Dropbox are also good options. They sync automatically and are not, and if your laptop dies or you spill wine on it, your data, you can access it from a different computer from the cloud drive. So just thinking about how will I keep my data safe is one big question of data management. Okay, Tom's thesis folder contains 47 files of all kinds. There are no subfolders, no logic to the naming, just everything dumped in one place. When his supervisor asked him to resend the survey questions, it took Tom 40 minutes to find the file, and he's still not sure that he sent the final version. All right. Now, this is about project structure, and this is having one file that contains everything related to your thesis is one problem, but I also hear about students who keep things in different places. So some of their stuff is on their laptop and other stuff is on the lab, the machine in the lab. And other stuff is in Dropbox. Some stuff is in Google Drive. And some stuff is in, my dad's laptop because mine wouldn't turn on that day, right? So often you've not only got all of your stuff with no organizational system to it, but your stuff is in all kinds of different places, right? And that just creates work for you when you have to find a specific thing, particularly when you come back after some time and have to find something because you no longer remember the system. There's a very vague system there somewhere, but you no longer remember what it is, right? So this one we're going to talk about explicitly in a little bit. This is all about project structure. How will you organize your project files? Maya had 5 versions of her analysis script saved as analysis, analysis 2, analysis new, analysis final version 2. When she came back to her thesis after a holiday, she had no idea which one produces the results that she'd actually written about in her results draft. She spent a full day rerunning each file just to try and match the output to the tables in her results draft, right? So this is about naming conventions, but it's also about version control, right? So it's a really good idea to have a system that you use to name your files that tells you more than simply this file has some analysis in it. But it's also a good idea to use a system that keeps track of the versions. Inevitably, you're going to be scared of overwriting things, right? So you want to have a system that will do a better job of keeping track of which is the latest version than analysis final version 2, right? Maybe it could be that analysis new is the latest one. We don't really know, right? So having a system by which you name your files that's consistent and that embeds some kind of version control in the names of your files is a really good idea. Okay. When Qualtrics exported Josh's survey data, every variable came up with a label like Q1, Q2, Q3, right? Warning, that's the default. So in Qualtrics, if you don't change that, so when you write a question, there's a place where you write what the participant will see, but your questions are kind of numbered, labeled. If you don't change those labels, when you export your data, you'll end up with a spreadsheet that is Q1 through Q372, right? So it's a good idea in Qualtrics before you even think about exporting your data is to change those labels to something that's meaningful, right? So Josh didn't realize that, and he exported his data and ended up with this spreadsheet that had Q1 through whatever. So he renamed them in his spreadsheet, but used abbreviations that made sense to him at the time. However, 3 months later, he's writing his results and he can't really remember whether WBT was a total well-being score or a time point label, right? and he hadn't got around to creating a data dictionary. We're going to talk about data dictionaries today. So you want to be really careful and conscious of how you name the variables in your data file. You want to do it in a way that makes sense to you, but also creates some structure in how things are related to each other. And you want to keep documentation that explains to your future self what you were thinking at the time when you labeled these things, because you won't remember. And yeah, it's really time consuming to reverse engineer what you did before to try and work out, in this case, is this a total score or a time point label? All right, so naming the variables in your data files in consistent but well-documented ways is important. Okay, Chloe had two data sources, a survey in Qualtrics and a reaction time task in Gorilla. She needed to merge them, so used a combination of participants' first names and birth months to identify each participant. Unfortunately, there were two participants with the same identifier, Sarah March, and she had no way of knowing which Sarah's survey matched which Sarah's reaction time data. So she had to drop both participants from her data. So that's an unfortunate mistake because you want to keep as much of your sample as you can. So you want to be thinking in advance, how will you create an identifier for each participant that is guaranteed to be unique, but also guaranteed to be consistent across data sets, particularly when those data sets are coming from different sources, right? So using a combination of their name and birth month is not a good idea because it's likely that you're going to get more than two people, but also not a good idea because you are embedding identifying information into the participant identifier. And ideally, once you get out of your Qualtrics spreadsheet, ideally your data doesn't have any identifying information in it anymore, right? For data safety reasons. And so it's a good idea to come up with a system that uses more pieces of information, or even is just totally random, that you have a separate sheet that you keep track of, all right, participant number, whatever, is this person. And then you can cross-reference your participant tracking sheet with your Qualtrics survey and your Gorilla reaction time task. Okay. Ben used an open text field when asking participants how old they were. The data came back with responses including 22, 22 is a word, 22 years old, 22 abbreviated years, and one person who typed old enough. This was not the only numeric variable in his data set that contained text values. And what should have been a 10-minute data input in order to get going on his analysis turned out to be many hours of manual data cleaning, right? So it's a really good idea before you start collecting data to think about how you can prevent participants giving you messy data that requires cleaning. And we're going to talk about how to do that in a little second. Okay. Halfway through her analysis, Priya realized that 34 participants had skipped question 8. She hadn't thought about missing data in advance, so had no plan for handling it, and wasn't sure whether the best thing to do was to exclude those participants entirely. Almost never the best thing to do because you want to keep as much of your sample as you can, use some kind of imputation method, or run a different analysis, because she was using an analysis that required that every participant had a score for that question. So she had to book an emergency meeting with her supervisor way too late in the game and decide what to do. So it's a good idea to think about how you will deal with missing data. Are you going to require participants to answer every question? Are you going to let them skip? And what will you do if they skip? How will that missing data value be represented in your data set? And what will you do about it? Will you just exclude the participants? Will you use some kind of imputation method? It's a good idea to have a strategy in advance. Okay. After graduating, Amir's supervisor wanted to include his honors dataset in a larger meta-analysis. The supervisor emailed Amir asking which items had been reverse scored and how the composite scores had been calculated. Amir couldn't remember, and there was no code book or data dictionary. The data set couldn't be used. 12 months of Amir's work contributed to nothing beyond his own thesis. He could have got his name on that publication, which would have been useful for professional program applications, but because he didn't keep good documentation about how the values that ended up in his data set had come about, that his data couldn't be used. So we're going to talk about the value of creating a data dictionary, or codebook as some people call it, and how you can use it throughout your thesis process to inform how you clean your data and validate your data, and how it will make your data much more shareable and usable by other people, which might have good career implications down the line. All right, during data cleaning, Ruby decided to exclude one participant whose response time on every trial was under 200 milliseconds. They were clearly not doing the task. She made the call, deleted the row. That's not a good idea, right? So as a general rule, you should never delete data. You can filter it. So you should, if in this case, if that participant was going to be excluded, it's a good idea to add a new column to your data. And anyone you are excluding because they did the task too fast, you code them as ones in this column. And everybody who did it in a good amount of time, you code them as zeros. And then you filter out the ones. So you should never edit the raw data, and you should definitely never delete data. But Ruby didn't know that. So she made the call, deleted the row, and moved on. At her thesis exam, her examiner asked her to justify her exclusion criteria. The methods section said nothing about response time exclusions because she had made the decision on the fly and forgot to write it down. So she couldn't really explain to her examiner why the sample that she described in her method differed from what ended up being analyzed. So it's a good idea to maybe in your everything notebook that we talked about a few weeks ago, to have a whole section about all the decisions you make about your data, so that you make sure that any decision that you are making about it ends up being described honestly and transparently in your thesis, so that you avoid a situation where maybe it's your thesis examiner, maybe it's your thesis project ends up being published sent in as a journal article. And maybe it's the reviewers of this journal article who maybe 12 or 18 months down the track, it takes a long time, who come back and ask you, what did you do? Why is this value not the same as this value? And if you've documented every decision you make about your data, then you can easily answer those questions, and it's not at all embarrassing. And lastly, the day after Marcus closed his Qualtrics survey, he exported the data for the first time. He discovered that his multi-select question had exported as 12 different columns instead of just one, and his Likert scales had exported as text labels rather than numbers, and his consent question was in the middle of the data set with all the participant responses, right? It's not really a problem, other than it took him a whole day to sort it out, time that he didn't really have. So this is an example of where it's a good idea to pilot your data export process before you actually let real data into Qualtrics or whatever platform you're using, right? Now, the nice thing about Qualtrics in particular is that there is a way that you can have it generate synthetic data. And so I think it's in the tools. You go into tools and say generate synthetic data. You can say I want 100 synthetic responses, and then you export those, and it will have randomly generated those values, but it'll give you an idea of whether your variables are giving you data in the range that you expected. It'll give you an idea of whether you're getting numbers like you want rather than labels. And whether your data looks like what you expect it to, and whether there are things that you can do in the setup of your Qualtrics to prevent some of that cleaning that you have to do down the track. So it's a good idea to generate some fake data within Qualtrics, have a go at exporting it, open the spreadsheet, and make sure that it looks like what you think it's going to before you let real participants at your survey. All right, so those 10 scenarios relate to these 10 questions. So this data management checklist, each of these 10 questions is something that I recommend you have a think about before you let participants at your survey. And having a think about these questions in advance could save you hours or days of suffering down the track. Now, I've chosen 3 of these to dig into a little bit today. And I've chosen these 3 because I think they have the biggest impact. So, not thinking about these 3 are the most likely to cost you lots of time. Yeah. So, we're going to talk about how to organize your project files. We're going to talk about how to prevent your participants giving you messy data and how to create a data dictionary and what you might use it for. All right, before we do that, does anybody have questions at this point that I can answer? I can see in the chat, Sarah, Sarah is asking about data cleaning in R. Yeah. So she says, do you recommend data cleaning in one R file and then running analysis in a new R file? Yeah, that's what I do. So I have an R file that is data cleaning, and it pulls in the raw data, does all the cleaning that I want to do, and then writes out a new CSV at the bottom that is the clean data. And then I have a different script for statistical analysis where I read in the clean data and do the analysis. And I'll often do visualizations and analysis together in an R Markdown file or a Quarto document so that you can write notes to yourself as you go along. So you're right. My data cleaning file is usually a separate R script, and my data visualization analysis is usually an R Markdown document or a Quarto document. Great, that's what you've been doing. Good news. All right, any other questions before we move on? Cool. All right. So first up, how are you going to organize your project files? Hands up or give me some kind of reaction in the chat, smiley face, thumbs up. If your project files sometimes look like this, right? So this is the example where there are, I don't know how many, there's maybe not quite 47. All your files that relate to your thesis are all in one folder all together. There's no organization. There is lots of duplication. So who knows which of these final, thesis later, final version 3, thesis really final, who knows which one of those is actually the document that we're working on, right? There is data files in here with notes, in here with slide presentations, in here with analysis scripts. This is a big jumbled mess. And the reason that this is a problem is that it's super hard to keep track of and find exactly what you're looking for at any one time. And you're at a huge risk of overwriting things, right? So this is risky, both in terms of the amount of time that you are wasting trying to find exactly what you need to work on today, but also it's risky that you might lose something in this jumble, right? So it's a really good idea to set up your thesis folder with lots of subfolders that each relate to a separate phase of your research. So rather than all in one, like red on the left, we ideally want something that looks like the file on the green one on the right. So you might want to have a folder that contains all the admin things. So your timeline, notes from meetings, the final approval of your ethics, maybe. You might want to have a folder that relates to your literature review with subfolders that have all the PDFs of things that you're reading, another subfolder that has notes that you are writing about what you read, keeping your Zotero stuff in a separate folder, yeah? A folder about research design that might have documents related to your questions or your methodology, your sampling plan, a separate folder that contains all of the things that you need to put together your ethics application. Another folder that is all about data collection. So you might have recordings from interviews, you might have survey survey results. You might have um, uh, protocols for your experiment in another folder. You might have materials that your participants, so examples of the actual survey questions in a different folder. In terms of data processing, what Sarah was talking about, it's a good idea to keep your data cleaning process separate from your analysis process. So in this folder, you might keep a separate one folder that has the raw data in it that you don't touch, and a different folder that has the cleaned data in it, and some scripts that turn the files that start their life in your raw data folder into the ones that are written out into your clean data folder. And this is where your codebook or data dictionary would go to. Once we're talking about statistical analysis, you might want to keep your figures and tables separate from the analysis scripts that you write and then the output files, right? In terms of writing, you might want to keep a folder that contains your drafts, labeling them in some kind of version control way so that you can really easily see what version you're up to. You might want to keep a folder that contains all the feedback from your supervisor, and then a separate one that contains your final product, including the document that has your final thesis in it, and then any appendices that went along with your submission, right? So it really is the case that thinking a little bit in advance about keeping your project organized can save you lots and lots of time in knowing where everything is, and then lots and lots of headspace about just wondering and worrying about things related to your thesis. Now, this pink link down here will take you to my a template that I created on my GitHub profile. So don't be scared of GitHub. It's really kind of like Dropbox in a way. In order to use this this template, you just need to use this green code button. It doesn't actually involve any code, and say download zip. You can download that zip file and put it somewhere on your computer that is backed up automatically, right? So you might want to put it in Dropbox. And then if you unzip the file, you'll have this structure, this file structure. And inside each of these files, there's a little text file that tells you how to use that folder, right? So this is a good place to start. It may be that you find that all of these folders is a bit much for you and you can like combine some of them, but it's a good idea to start with a really comprehensive template and then customize it to make it your own. All right, so you can use that link to get to the project template. All right, so it's all very well to like set yourself an intention to keep your project files organized, but in my experience, at least, sometimes well-set intentions, you just fall off the wagon, right? Once things get busy, things just end up piled on your desktop again, right? So I recommend you do a stock take now. So get out your notebook and say, all right, where is my stuff? Some of it is on this laptop, some of it is on another laptop, some of it's on a computer in the lab, some of it's on the shared drive, some of it's on good, right? Where is it? And then pull as much of it as you can into one location that does an automatic backup. I recommend Dropbox or OneDrive or some backed up server that your lab uses, right? And then organize those files in that one location by project stage. And then try to work within that structure, acknowledging that you will fall off the wagon. And so you might want to set a recurring calendar appointment with yourself to do a monthly stock take. So maybe on the first of the month, you spend an hour or so just checking in with yourself. Is this structure working? Do I need to change these folders to make them work better? Have I accidentally left some things on the lab computer that need to be put into my project structure, right? So do a stock take now, pull everything into one place, but then acknowledge that you'll probably have to check in with yourself once a month or so to work out how well that system is working. Okay. How do you prevent your participants from giving you messy data? So Darren Daly is a epidemiologist, I think, from Canada, and he has he works with data that lots of different people send him, and he has all kinds of hilarious blue sky posts about data management challenges that he has to deal with because he's dealing with other people's lack of data management skill, which must just be the worst job. Like, it's all very well to have to spend a lot of time fixing your own mistakes, but when you're spending a lot of time because someone else didn't do the right thing, yeah, that must just be frustrating. So he posts things like this. How old are you? Unique responses, right? So when you let your participants use an open text response, you're essentially asking them to write whatever they want, which means that they can interpret your question however they want, right? I love this person who says to answer to how old are you? His answer is okay. It's like, is that appropriate? I don't know. It's kind of funny, right? So how do you prevent your participants from doing this? Oh yeah, here's some examples. Age is a problematic one. People will give you all kinds of things. Date is also extra problematic because you can't assume that your participants write dates in the same way you do. And date formats in data are a whole challenge. So if possible, restrict the way participants give you dates. Locations can be written in many different ways, even though these are kind of all the same. And if you're asking people about something that has a unit that you care about, make sure that you convey that to them and ideally restrict the range of responses that they can give you. Because some people, when asked how far do they travel to work, might say 15 minutes, which is not a useful piece of data. Okay, how to prevent this? Use multiple choice questions where possible. So the age thing is an interesting one because you might want to ask yourself, do you care exactly how old people are? Like, do you care that this person is 21 and this person is 23? Or do you care mostly that you know how many 18 to 25-year-olds and 26 to 35-year-olds you have, right? So even with age, maybe you don't need the level of precision that requires people to actually write their age. Maybe you could make that a multiple choice question and end up, which of these age brackets do you fall into, right? But if you need to use an open text response, make sure that you're adding validation. Now that means you can, within Qualtrics or any other survey platform, you can restrict the range and data type for an open text response. So to the question, how old are you? You might require that it's a text entry, but require that the content type is number. And that means that when people try to write 27 years, it won't let them do it. It will say, please enter a number, and then they'll have to write 27, right? And you can also restrict the range. So that people don't give you ridiculous answers, you can say, all right, the content type needs to be a number, and it will only accept numbers between 18 and 100, right? For dates, it's a really good idea to make your question type a calendar. So let's imagine that you want to know when this person began treatment in your trial and you want a date. You can set the question type to be calendar and require a single date, but also require a date that falls within a particular date range. So you know that your trial ran between January 1st and June 1st. So you can require that they give you a date between January 1st and June 1st, so that both your date in your data will actually be a date and they'll all be formatted in the same way, but also dates that are impossible won't be allowed. Okay. Okay, and then the last recommendation I have is creating a data dictionary. Now, a data dictionary is simply a reference guide for your data set. It's a document that explains exactly what each variable means, how it's coded, and how it should be interpreted. And it's super useful to create one of these, both for anyone who's likely to work with your data in the future, but also for you, because you're someone who's going to work with your data in the future, right? So you'll be surprised how little you remember about the decisions you make in setting up your Qualtrics when you come to analyze your data 6 months later. So this is like a guidebook to your data that you create ideally before you start collecting, but even if you have data already, it's actually useful to reverse engineer a data dictionary from data that you already have, whether that's pre-collected by you or somebody else, just to familiarize yourself with what's in this data and how should I be interpreting it. Crystal Lewis is a friend of mine. She is the data management queen, and she is a big proponent of data dictionaries. She has a great blog about this, which you can get at these pink links. She's written this book called Data Management in Large-Scale Education Research. All the recommendations in that book are equally relevant to psychology research as education research. And she has a great talk on YouTube where she did a talk for the Center for Open Science about data management and how to embed best practices with reproducibility and replication in mind. So I highly recommend everything that Crystal has written and put out on the internet as extra resources for what I'm about to share with you. She's the expert. All right, so what you want to do to create a data dictionary, you essentially just create a spreadsheet that documents things like information about each of your variables. So you want to document for each of your variables what the name of it is in your data. So this is what you've changed from question 1 through 300 and whatever it is, but also a label for that, right? So this stress score T1, you might write time point 1 stress score from this scale, right? So you want to translate what that variable name is in lay terms. Sometimes it's useful to also include a column that is the question wording. So what did participants see for this item? So in that case, you might say, how stressed have you felt over the last month? Is what participants saw. And then the source, the scale and or subscale that that variable came from, right? So information about each of the variables, the values. So for each variable, you want to note what are the allowed values in that for that variable. So 1 refers to, in this case, strongly disagree. 5 refers to strongly agree. Any rules that you have for missing data. So in some data formats, missing data appears as 99, which you've got to be aware of, because if you try and calculate the average age of your participants, and some of them, the value is 99, not because they're actually almost going to turn 100, but because that value is missing, you want to know that and deal with it before you start creating descriptive statistics. And what type of data is it? Are we talking about numeric values, categorical values, strings, or dates, so that you can check when you come to validate your data that there are only numbers in this column, right? You can also note tasks that you have to do to the data. So any transformations, a lot of scales will have items that you need to reverse score in order to accurately calculate a summary score. And in other cases, you'll want to document variables that you calculate or compute. So the total stress score is the mean of items 1 through 10, for example. And then other things that are sometimes useful and are sometimes not relevant. So if you have logic within your Qualtrics survey that has skip logic in it. So if you answer this, then it skips down to the next section. You want to document that kind of thing in your data dictionary. You want to, in order to kind of anticipate where you might get missing data, it's a good idea to note whether an item is required or whether participants are allowed to skip it. And then in very complex or longitudinal work, you might want to note who in your participant does this measure, right? So imagine that you are testing both kids and their parents, and there is a parenting stress scale that only the parent does. You want to note in your data dictionary that that is a scale that the parent, you'll only have parent data for that. And then in longitudinal work, you might want to note which time points does this measure appear in if the measures change across your study. Okay, what does it look like? So it's actually not as complicated as you might think. This is an example from Crystal's blog post from a study, a school study. So you can see here that there is a column for scale. Not all of the variables have information in this column. So the student ID and the survey date are not related to a particular scale. But for these items from the GAD scale and the PAL scale, there is information about what scale they're from, but also for the PALS one, what subscale those items relate to, right? So there are variable names that you create in advance. So you can often create your data dictionary before you create your Qualtrics survey, and then use your data dictionary to rename the question 1 through 300 and something with variable names that make a lot of sense to you, right? This label is a description of what that variable actually is. The values tell you what the allowable range is or what the numbers refer to, right? So it's interesting here that on the GAD scale, 0 refers to not at all, and 3 nearly every day. But on the PAL scale, 1 refers to not at all true, right? So those kinds of little inconsistencies are important to keep track of, particularly when you come to do your analysis, right? Information about missing values. So in this data set, minus 99 is an indication that the data was skipped, that item was skipped for that participant. Information about what type of data is in each column. Transformations that you have to do. So the couple of items on the PAL scale needed to be reverse coded. And then this universe column is which groups of participants did that particular item, right? So this is a longitudinal school-based study. So in some of these items, you'll have data from children in all grades and others only 9 through 12, right? So this link takes you to a data dictionary template that Crystal has created on the Open Science Framework. It's a really good idea to start with hers and then make it work for your experiment, right? It's usually the case that there is a separate data dictionary for each instrument or each scale, your survey would have one, your experimental data would have a different one, or you can keep them in tabs within the same spreadsheet, yeah? Okay, using your data dictionary. So in an ideal world, you create one before you've even created your Qualtrics script, and you use the range of values to set validation rules within your Qualtrics survey. But if you've already done that, you can create your data dictionary at any point along the way, and it's still going to be useful, right? So you can create your data dictionary after you've collected your data, and then use it to make sure that you are doing the kinds of cleaning that you need to do. So getting rid of values that are out of range, or remembering to try and do that reverse scoring. You can create it after you collect your data and use it in the validation process. So making sure that you have the right kind of, so the values that you expect to be numeric are numeric, and the values that you expect to be strings are strings, that kind of thing. You can use your data dictionary to do that. But the most useful thing about it is that this documentation is a gift to whoever is using your data in the future, whether that's you or someone else. So ideally, it would be great if once you've finished your honors project, you were able to publish it. That might involve putting data together with other students in your lab. And so it might be a process that takes like 1, 2, 3 years. Could take a long time, right? But by leaving your data really well documented with a data dictionary, it's much more likely that next year's honors student who's going to run that little thing that you suggested in your future research is going to be able to take your data and use it and then give you credit with an authorship in the publication, right? So making sure that your data is really well documented is a gift both to your future self in the coming months, but also to the scientific community, whether that's people you know in your lab, or you could really well documented data you can give away and make freely open on OSF so that other people can use it. So this blog post, using a data dictionary as a roadmap to quality data, that Crystal wrote is really recommended. She works through the whole process, right? Now, I know lots of you are saying, Jenny, this seems totally tedious. Is there a way to shortcut this? And yes, apparently, I haven't tried this, but Crystal has, and I trust her. You can ask AI to help. So this blog post, creating data dictionary drafts using Claude, Crystal wrote a couple of months ago, and she essentially gave Claude a Word document version of her survey and the template that you can download off OSF, and this prompt, and asked it to create a data dictionary. Now, you'll notice that she gave it quite specific instructions. So, as you all know, I'm sure, working with AI, the better the instructions you give Claude, the better job he does at whatever you want him to do, right? So she's saying for the name column, use snake case, naming convention. So that's when you have a little dash in between each of the words. Start all variables with T underscore to donate that this is a teacher survey. Use naming conventions that clearly convey what the variable represents. If the variable comes from a scale, use a short abbreviation for the scale. Use the values column, use the pipe, which is like the straight up and down thing that you'll find below your delete key, as a space delimiter between response options, and name the data dictionary blah. And she said that it did actually, she gave it a simple, some demographics and a couple of scales in a Word document, and it did a really good job as a first draft. There were errors to fix. So don't trust it, as always, don't trust AI to do a perfect job. But to avoid all the really tedious typing that this involves, AI can really help. All right, so take home message, ask yourself these 10 questions now to save hours and perhaps days of suffering later. I'm happy to take any questions. If you have to run away, totally fine. Before you run away, I just want to let you know about some Ask Me Anything sessions that I'm running over the next few weeks. So these Friday lunchtime every second week is turning into Ask Me Anything small group coaching. So I've got a few themes lined up. The next one next Friday is about general discussion writing. 2 weeks after that, about getting what you need from your supervisor. 2 weeks after that, managing your time. And 2 weeks after that, literature review and knowing that you've read enough. I haven't quite got registrations up on my website yet, but they will be there by Monday. So check in on my website on Monday. This is a small group situation, so limited to 10 people. They're 90-minute sessions. It'll start by me running a little practical exercise, hands-on learning with 10 other people who are in the same boat with you, and then as much time as we need to answer any questions about anything. So even though next week's session is going to be about general discussion writing, if you came with a question about data dictionaries, I would totally answer it, right? So 90 minutes in total with just you and 9 other people. Much more interactive and hands-on than this. This is like small group hands-on learning. So have a look on my website on Monday if you are interested in that. And other than that, I'm happy to answer any questions about data right now, if that would be useful.
Hi, Jenny. It's Tiana.
Hi, Tiana.
I just wanted to say these have been so helpful for me, like
Oh,
to think of things that I haven't even thought of just yet. So yeah,
good.
your advice and your slides are amazing. So thank you so much.
You're welcome. No problem.
Thank you.